Just 4 light-years from Earth, a small shadow circles a red dwarf. Its year lasts only 11 days, but its star is so furious that a single flare can paint the sky in violet fire. Meet Proxima Centauri b, our nearest Earth 2.0 candidate, or a crimson mirage. Proxima Centauri is the smallest member of the Alpha Centauri system. It's hard to see with the naked eye. Its light is dim, its hue red, and by nature it is highly restless. It is an M-class dwarf, the most common type of star in the universe. Orbiting this star is Proxima b, the closest exoplanet humankind knows. Roughly 4.2 to 4.3 light-years away, practically next door on a cosmic scale. This planet was noticed in 2016 through tiny wobbles in its star's spectral lines. The technique we call the radial velocity method reads the gravity of an orbiting planet from the star's back-and-forth jitter. Data gathered over many years showed that Proxima b circles its star in about 11 days and has at least an Earth-like mass. The phrase approximately Earth mass matters here because no transit, no crossing in front of the star has been detected. That means we still do not know the planet's radius and therefore its true density. Is it Earth-like or a heavy, iron-rich super-Earth? The question is still open. So why are we this excited? Because despite being very close to its star, Proxima b sits, thanks to that star's faint nature, at temperate distances we call the habitable zone, where liquid water could be possible. The key phrase is, could be. The habitable zone is no guarantee. It is simply a range that offers a chance in terms of energy balance. For a planet this close to its star, the first physical consequence that comes to mind is tidal locking. Like the moon always showing the same face to Earth, Proxima b may have one face in perpetual day and the other in unending night. On the day side, a huge red star hangs in the sky. On the night side, endless darkness and killing cold. So where could a habitat exist on such a world? Climate models in recent years suggest that if the planet has a sufficiently dense atmosphere and at least some water, mild conditions could form right along the day-night boundary, the twilight terminator zone. Atmospheric circulation and ocean currents would carry heat from the star, preventing the day side from becoming a furnace and the night side from being lethally cold, allowing certain regions to find a balance. Some models even suggest that with the right atmospheric composition and pressure, not just a narrow ring, but a much broader area could fall within the habitable range. But the romantic part of this story ends here. Because Proxima Centauri is an M-dwarf and extremely active. Flares frequently rise off its surface, strong magnetic fields twist and snap the star's plasma, triggering sudden energy releases. These flares produce brief yet dramatic brightenings in visible light, ultraviolet, and X-rays. Some are so powerful that the star can appear thousands of times brighter for an instant, especially in ultraviolet wavelengths. What does that mean for the planet? Increases in ultraviolet and X-ray radiation can cause serious chemical erosion in planetary atmospheres. They can quickly deplete an ozone layer, exposing the surface to harsh UVC. High-energy particles can shatter molecules in the upper atmosphere, letting light species like hydrogen escape to space. In short, frequent and intense flares can, over the long term, gnaw away at a planet's water and atmosphere. That is why Proxima b wavers between the nearest potentially habitable world and a bare rock, a riddle in between. So is everything this gloomy? No. A planet's fate depends not only on its star, but also on its own defenses. A thick atmosphere, the right chemical mix, a strong magnetic field, and a sufficient water inventory can buffer a star's fury. On Earth, our magnetic field and atmosphere weaken and steer solar storms. We do not know whether Proxima b runs a core dynamo or how strong a magnetic field it might have. But that is the beauty of science. We are looking for ways to test this unknown. Now let us ask this. Is the Proxima system just a single planet? Clues about the short-period low-mass Proxima d suggest at least one more small world close to the star. There are even studies hinting at a possible longer-period planet farther out. This picture suggests it is no accident we see compact, multi-planet systems around M-dwarfs. In other words, Proxima may not be alone. It may host a mini family of worlds. Understanding that family also illuminates Proxima B's past and present. Processes like interplanetary mass exchange, early bombardment, and the transport of water and volatiles directly shape the planet's current climate. What about the future? First, with longer and more precise radial velocity campaigns, we will measure Proxima B's mass and orbital details better. We may not detect a transit, but new techniques are being tried to catch indirect signatures such as reflected light or thermal emission. At the same time, building a more complete statistic of the star's ultraviolet and X-ray activity will help us quantify the width of the habitability window. How often do flares occur? How intense are they? And at what energies? How do such events transform a planetary atmosphere over tens of millions of years? The questions are clear, and so are the observations to answer them. And of course, there are engineering visions that go beyond mere dreaming. Concepts like breakthrough starshot aim to push gram-scale space sails to a significant fraction of light speed, with giant laser arrays on Earth, reaching Alpha Centauri in on the order of 20 to 30 years. Today it is a path full of massive technical hurdles, but once upon a time, the very idea of exoplanets felt like science fiction. Now we know thousands. Why not send microscopic yet smart couriers to this neighboring system someday? At the center of all these efforts lies a single curiosity: life. Could Proxima b have managed to retain an atmosphere? Could an energy-matter cycle, like a rock-water-air loop, operate at its surface? Might mild regions have formed along the twilight belt, misty lakes, cloud-draped plateaus? Perhaps not. Perhaps stellar storms have stripped the world bare over centuries. But science does not just like maybes, it knows how to test them. In short, a quick recap. Proxima b, the closest exoplanet to us, a roughly Earth mass candidate orbiting within its star's habitable zone, very likely tidally locked with a sharp day-night split, and on top of everything, exposed to the space weather of an active red dwarf. Taken together, these facts write two opposing stories. The hopeful one, with a thick atmosphere, some water, a working magnetic field, and vigorous heat transport, life might carve out a niche on a twilight world. The harsh one, stellar flares may have swept away ozone and water, turning Proxima b into a naked rock. Which story is true? We do not know today, but we are closer than ever to finding out. Better spectrographs, longer observing campaigns, smarter data analysis, and perhaps tomorrow's bold flight technologies, all are moving us toward this question: can life hold on at our nearest neighbor? Perhaps Proxima b will change our sense of what is possible in the universe. Perhaps it will remind us how fragile life is. In either case, curiosity will win, because curiosity is what makes us look up, build telescopes, put formulas to paper, and never let go of the question, who is out there? Thanks for coming with me to the shores of Proxima b. If you enjoyed this journey, do not forget to subscribe and share the video. In the next episode, let us crack open the door to another world around another star. Maybe one day, that door will truly open.